Okay, here's part 2, HHO spark plug. If you haven't seen part 1, you can look at part 1 to understand the circuit. Otherwise, if you're good with circuits, you should be able to see what's going on here. The only unique thing here is the HHO spark gap. This all started when I was trying to design a way to explode hydrogen in a piston. Instead of making hydrogen and then putting it in our engine or something like that, I thought, well, why can't we take hydrogen and explode it right inside a cylinder? See how much pressure there is, see if we can maybe make a little steam engine type thing using a hydrogen piston. So I attempted to see how to fracture water, did a lot of research on different topics, and after reading about plasma experiments and underwater explosions and the effects they have, the sound waves, things like that, I thought I'd give it a try. So I took out the microscope, put the spark gap under some water, and have a look what's going on here. Now I was watching as I was adjusting the frequencies and changing the frequencies around, and I could notice that I could get the bubbles moving and actually expanding fairly quickly. And at the same time you can see I'm getting ignition happening underneath. And all of a sudden I noticed that some of the bubbles were also exploding, like there was almost a cascade effect. And if you watch closely, although the camera doesn't pick it up very well, there was one that just went by there, you will see there's a cascade effect happening on the hydrogen bubbles, or the bubbles which are hydrogen and oxygen. And of course when that happens, it turns back to water. So this is when I thought about trying this in a sealed unit. Now again, it was on to the old internet to research and read and find out, and according to that research, exploding the hydrogen and having it turn back into water, well, there's no energy gain. I did find this big controversy though around plasma and some results that some guys had come out with saying that, you know, the heat generated by the plasma reaction in the water was far exceeding over unity, and you know, and then I seen it was debunked by another set of scientists, and so nobody's been able to prove it or show it or anything like that. So I found this very intriguing. Now, all that reading about ionization and the static electricity and the high voltage and all this stuff, this I started to come up with this little test right here. And what it is again, we're looking through the microscope, but it's more like two flat plates that are very, very close together. And right now, I'm only using the transformer, the step-up transformer, at around 600 volts. So this spark gap, to bridge that gap, is 600 volts. But the other thing that I had to do was I couldn't use tap water or anything like that. It has to be pure water. It snowed the other night, and lo and behold, the snow water worked the best. So after cleaning my microscope a few times, I got smart. Put some cellophane over top of the spark gap. But here we go. I'm getting it tuned up pretty good here. Instantly we're fracturing that water, and at the same time we're almost doing some plasma. Oh, but I have to watch my words, or cold fusion. I decided to create a spark gap inside a sealed vessel. My first attempt at this was a pen. Took apart a pen and cut it up and put in a couple of pins inside there and tried to seal them off from the water as best I could, and fired it up and give it a try. Well, as you can see here, when I fire it up, it's splitting the water pretty good. But now the water's split and gee, it's not working. What's going on here? Yet my other experiments work good. Well, it's time for an upgrade. I sat down and I figured out what I needed to do, and here's the end result of the product. This is the HHO spark gap. It looks pretty simple, but there's actually a lot to it. I'll try to explain it as best that I can so that somebody trying to recreate this can do it. Okay, let's zoom in a bit on this, and what we're going to do is right now I'm going to concentrate on the main concept how this works. The green is basically plastic. The glass, what this is this is a 2 amp fuse. There's thick enough glass to stand for the heat. and as well to work with. I did break a couple, but I didn't cut myself, so that's good news. Looking a little closer, we'll look at the top side here. Got it zoomed in. Basically what I've got here is a pin that's made from aluminum with a stainless steel end, and the stainless steel end is flat so that I can make up those microscopic flat plates in between there. The gap now is a little wider. I had to increase my voltage. That's what the multiplier is for. Here's the other side, the ground side. As you can see, there's more bared there. It doesn't matter if the ground side is in the water. Let's take a closer look now at the positive side. Now the positive side, as you can see, the plastic is coming along up to a certain point. Now I have a threaded rod going inside an aluminum housing there, and then on the end, the yellow part there, well, that's the stainless steel tip. The blue part, well, that's a shrink wrap that I've put around to help seal the water. See, the thing about the positive side is you need to keep the water away except for the very end of the pin. Now looking at the other side, it's the same idea, only in reverse, only this diameter of this is smaller so that I can allow water to pass down there, or water to sit in there, kind of like a little sump area. Now we're going to have a look at the bottom. What I've created here is it's like a reservoir. All the water on the bottom side of the HHO plug sits down there with a baffle or a diaphragm, and that's basically a balloon capped over the end of my reservoir. And what happens is when the water starts to fracture, well, then we need a place for expansion, because before, when it expanded, it just kept leaking and I couldn't get a sealed unit to properly test it. So now, with this diaphragm on here, I can see how much pressure is actually being developed in there and what happens to the pressure when there's an explosion, or when the spark plug is running. I can feel on the diaphragm if there's any waves or wave pressure inside the vessel. So looking now again at the bigger picture, you can see that on the bottom, that acts as a water reservoir. See, the spark plug stands upright. So there's the gas builds on the top, and as the gas builds, the gas starts to fill up the area up there, and the expansion pushes the water down, and that allows us to change resistance. Oh, speaking of resistance, I have to explain the resistance and show you on the scope what happens with this spark plug. But the main point of this build is that you need that reservoir and you need that expansion area, and as well your positive on the top needs to be sealed right as close as you can down to the end of your pin, and your pins need to be stainless steel. Palladium is recommended. I guess that pretty much covers the build or the design so far of the HHO spark gap. In the next segment, we're going to go and we're going to look at exactly what happens in here when it's pulsed. We're going to go back and we're going to look again at our circuit, and we're going to see what kind of things were done in our circuit to make the hydrogen react the way it did in the earlier tests, so that we get a fast expansion of bubbles. We then build up our sealed container with gas. We explode that gas, hopefully by cascading the hydrogen bubbles and oxygen bubbles and turning it back to water, and have this continue and see what happens.